All right, this is the Geometry Unit 5 Lesson 2 video over triangle bisectors. So in this lesson, they are introducing this idea of the center, different types of centers of triangles. And so there are two that they introduce in this lesson and then two others that are introduced in the following lesson. And so what I'm going to do is I'm going to summarize the material from the lesson, and then I'll work through the proofs here on the video and then give you some tips for how to do some of the other questions. So we already learned what what a perpendicular bisector is and what an angle bisector is, and that's what we covered in the previous lesson. So in this lesson, we're going to be looking at the different centers of a triangle that are created when you draw those. So looking at this note real briefly, we see that when I take each of the perpendicular bisectors and I intersect them, see each of these is a perpendicular bisector of those sides, the place where they meet is called the circumcenter. And when I take the angle bisectors and I make the intersection of those three lines, that point is called the incenter. And you can see those are not the same point. They are located in different places. So that's the first big idea here from this lesson. So let me jump to a different note here. And let's talk about the circumcenter. Sorry about that. Let me zoom out. What's going on there? Weird. Let's zoom out. Let's reload. Sorry about that. Huh. All right, let's try to fix this real quick. There we go. All right. There we go. Sorry about that. So the circumcenter. So the circumcenter, like I said, is created by the intersection of the angle, the perpendicular bisectors of the sides. That's the first point here. The things we need to know about the circumcenter is that the circumcenter is equidistant from each vertex. We already know because they're perpendicular bisectors that they are going to divide each side in half. And then also we can see that it divides the triangle into 6 right triangles. So let's jump back over to our diagram here where we have the image. And you can see the perpendicular bisector, all of those things are true. It divides each side into 2 equal parts. It is equidistant from each corner of the triangle. So this point here in the center is equidistant from the corners. So if I were to draw a line from each corner to that point, those would all be the same distance. So that's kind of a key kind of feature. All right. So it divides each side in half, and it divides the triangle into 6 right triangles. All right. So let's look at the next part that we need to look at, which is the first proof that comes up in the lesson. So let me jump over here. So we've gone over the information about circumcenter. It says here the circumcenter theorem, which we just discussed, is that the circumcenter of the triangle is equidistant from each vertex. Then they're going to have us do a proof. So I'm going to go over this for you. Like I said, we'll do the proofs together on the videos. Let's read through it. So we have some givens. Line L is a perpendicular bisector of AC. Okay. Line L is a perpendicular bisector of AC. That means this line right here is a perpendicular bisector. Line M is a perpendicular bisector of BC, and line N is a perpendicular bisector of AB. Line M, N, and N intersect at point P. So that right there is what we call the circumcenter, right there, point P. So let's see what we can do here. So we have our given, and then it says that P is the circumcenter, and that's because the definition of circumcenter is that it's the intersection of the perpendicular bisectors. Then it says that AP is equal to CP. That's the bisector theorem. So we know that AP is congruent to CP. That's this triangle here. So we already proven that those two are congruent to each other in blue. Then it says M is the perpendicular bisector. So you see they're about to repeat the same logic that we did in numbers 1 through 3. So let's follow the same thought process. In the second one, it says P lies, or in the fifth one, it says P lies on the perpendicular bisector BC. That's the exact same as statement 2, so it's going to be the same reason. Definition of circumcenter. So that's going to be answer choice F. There, choose answer choice F. All right. Then we need our next statement. So let's look at BC. So what would BC? Well, that would be related to, oops, sorry about that. Let me erase that real quick. Redraw this in there. Yeah, okay, there you go. That's going to be this side right here. It's congruent to CP. So we'll have proven that BP is equal to CP. That's answer choice H. Again, same reason. Perpendicular bisector theorem coming from answer choice 3 up above. That's going to be answer choice A. So you can see we have the same exact process for 4 through 6. And then we take 3 and 6 together and we say, well, if this is true and BP is equal to CP, then we can prove those together to say this. And that is just simply the transitive property of equality, answer choice E. All right, so make sure you get the answers down that you need for that proof. And then let's move on to the discussion of incenter. So the incenter of the triangle is the part of the triangle that's the intersection of the angle bisectors. So it's the parts that bisect each angle and they meet together at the incenter. All right, let's look at our details about this. It says it's created by the intersection of the angle bisectors. Okay, got that. It's equidistant from each side at a right angle. Okay, so that's important, equidistant from each side. Let's take a look at that in our diagram. So that means that the distances on our diagram from here, here, and here are going to be the same distance. And then we have it cuts each angle in half, which we already knew. That's the definition of what an angle bisector is. All right, let's jump back over here. That's our incenter theorem. It's equidistant from each side of the triangle. You can see a little diagram there. So questions number 2 through, 2 through 12 is all vocabulary. So use the vocabulary from the lesson to answer that. Make sure you're making good notes of those so you can have them for the test. Then we get this one right here. It says P is the circumcenter. Okay, let's take a look back at circumcenter and make sure we know all the info we need about circumcenters. So here's what we need to know about the circumcenter. So let's take us to see if any of this helps us here. So they've given us a bunch of information here. They've written it all out, but they've also gone ahead and drawn it up here in the diagram. So everything you read here is also already represented in the diagram. So then it says, what's the measure of KP? So KP is this part right here. So KP is going to be related to this JP and this LP. And the reason I know that is because if we go back over here, we can see that we know that the circumcenter is equidistant from each vertex. So if I go back over here, that means that these sides all have to be the same length. So let's go ahead and draw that on there. Let's use a different color here. So these 3 sides all have to be the same measure. So that tells me that it's going to be 19 centimeters. See if that is one of our answer choices. Yes, it is 19 centimeters. Then it says, what's the measure of XJ? Well, XJ is, let's use another color for that. XJ is right here. That's going to be related to this one right here. So let's see if that 14 tells us anything. Well, we know that it divides each side in half. We see if that's been divided in half and XK is 14, then XJ also has to be 14. I'm going to let you do the JL problem. use the information you have there. And I'm also going to let you do the JPY question as well. To do that, you need to note that this is a right triangle. You already know this is 35, and you know that this is a right angle. So what is the missing angle measure? What is the measure of that angle right there? So I'll let you finish that one out. And then you're going to do number 14. You're going to use the same exact kind of thought process of what I just got done doing, but this time you're going to be using the information about incenters. So take the look at the in-center stuff, and that's what you're going to use right down here for number 14. Number 15, this is a long drawn explanation to say that in an equilateral triangle, the incenter and the circumcenter are the same, only in equilateral triangles. So I'm going to tell you how to do that one. And then we'll do the proof here together. All right. It says PT bisects STR, PR bisects TRS, and PS bisects RST. So right now, this tells me that this is the incenter, and then it's going to be part of our proof. Then we have the perpendicular line segments here, here, and here. All right. So in here it says the given is that PR bisects TRS. That therefore P is the incenter of RST. That's the definition of incenter. It's right here. Then PX equals PZ. So that's because those are the distances from the center. And if you remember, in an incenter, the incenter is equidistant from each side. That's where that's coming from. Then it gives us another one, and we're going to follow the same process. Look at this. The process we followed here is going to be the same as the process we follow right here. So let's follow the same process. Well, P is on the angle bisector. That's going to be the definition of angle bisector, or definition of incenter. It's E. Number 6, PZ equals PY. We should be looking for a statement similar to what we have in number 3. And the reason is angle bisector theorem, A. And then lastly, we use the transitive property of equality to say that those three are all equal to one another. All right, so that's it there. Make sure that you have everything from those proofs, and I will post the next video tomorrow. Oh, one other thing. There's going to be some notes, important kind of diagrams in the notes, so make sure you are taking a look at those.